Hello, dear student. Now we are going to see exercise 13.1. Two cube, each of volume 64 centimeter cube are joined end to end. Find the surface area of the resulting cuboid. Definitely when two cubes when attached each other, then definitely it will nothing but the resulting structure is cuboid. Now, if each cube has the volume 64 centimeter cube, suppose the side of one cube is a centimeter. So volume is given and we know the formula for the volume of the cube is side cube, that is 64 equal to a cube, side is 4 centimeter. Now when two cube attached to each other, then end to end, then we get cuboid of the length 4 plus 4, 8 centimeter. Breadth 4 centimeter and height 4 centimeter, and just we have to substitute the in the formula. So 2 LB plus BH plus LH. So just we have to substitute the formula. We got 160 centimeter square. So in this way we can find out the value. Question number 2. A vessel is in the form of hollow hemisphere. So hollow hemisphere is this structure. This is the structure of the hollow hemisphere. This is the structure. The diameter of the hemisphere is 14 centimeter. So this is the 14 centimeter total diameter. So the radius is 7 centimeter and this is 7 centimeter. This is 7 centimeter. And total height of the vessel is 13 centimeter. This is the 13 centimeter. Now find the inner surface area of the vessel. Now hemisphere is mounted by a hollow cylinder. Now this is the hollow cylinder is this is the part of the hollow cylinder. So based on the given information, based on the question, first of all there are two combinations in this structure. First structure is this is the hemisphere and second structure is this is the cylinder. So for the cylindrical portion, if you will see, then AB, the length of this and this length is same. So AB equal to DC equal to 14 centimeter because it is surmounted. So radius is OB equal to O dash C and this is equal to O dash P, that is 7 centimeter, that is 14 by 2. Now total length of the vessel is 13 centimeter. So length of this cylinder is total 13 minus 7 is 6 centimeter. So for hemispherical portion, height radius is equal to the height of hemisphere, and inner surface area of the vessel is nothing but the curved surface area of the cylinder plus curved surface area of hemisphere. So we know the formula 2 pi RH 2 pi r square, curved surface area of the hemisphere and curved surface area of the cylinder. So just we have to substitute the value 2 into 22 by 7, r value is 7 into h value is 6. See, this is for the cylinder, and 2 pi r square 2 and this is given 7 radius. So after calculation we got the total inner surface area of the vessel, that is 572 centimeter square. Third question, a toy is in the form of cone of radius 3.5 centimeter. Now this radius is given 3.5 centimeter, surmounted on a hemisphere of radius same radius. So this is the hemisphere of the same radius. So this radius is 3.5 centimeter, then this depth is 5 centimeter. The total height is 15 this total height is 15.5 centimeter. So based on this, the given information, we can find out the height of the toy. So total height of the toy is given 15.5 centimeter. So for hemispherical portion, if you will see, then OC equal to OD. This part is always equal in the hemisphere and this is equal to 3.5 centimeter. Now for the conical portion, for the cone, OA equal to total 15.5 minus 3.5, we will get 12 centimeter in the radius. So total surface area of the toy is curved surface area of the cone, that is pi RL. This is the formula, pi RL, and curved surface area of the hemisphere, that is pi R, 2 pi R square. So pi RL, for the L value, this is nothing but the square of this and this. So h square plus R square. So just we have to substitute the value, pi 22 by 7, R 3.5, h square 12 square, 3.5 square, and 2 22 by 7 into 3.5 whole square. And just we have to take the common and solve, we get the result. So this is the 214.5. So easily you can solve this. Now next question. A cubical block of side 7 centimeter is surmounted by a hemisphere. What is the greatest diameter of the hemisphere? Can have, find the surface area of the solid. Now it is given cubical block is surmounted by a hemisphere. So a structure is like this. This is the cube and this is the hemisphere. So diameter of the hemisphere must be equal to the side of cubical block, and it is greatest diameter of the hemisphere. Now this is 7 centimeter, then definitely cubical portions age is 7 centimeter, this is 7 centimeter, then this is also 7 centimeter. Now for hemisphere, diameter is 7 centimeter, so radius is 7 by 2 centimeter. Now total required surface area of the solid. Surface area of the solid we can find out. Total surface area of the cube. This is the total surface area of the cube. That is 6 edges are there. So 6 into edge square. Curved surface area of the hemisphere. So curved surface area is 2 pi R square minus area of the circular base of the hemisphere, because we can't see this portion because this is in the bottom of, and this is the bottom of the hemisphere which is touched with the cube, so we can't see. So we have to subtract the area of the circular base. So 2 pi R square minus pi R square. So 6 into edge square plus 2 pi R square minus pi R square. We have to substitute the value and get the answer. Now a hemispherical depression is cut out from one face of a cubical wooden block such that diameter L of the hemisphere is equal to the edge of the cube. Determine the surface area of the remaining solid. Now whatever the question earlier we discussed, it's the same question. So side of the cube is equal to the diameter of hemisphere. Now this is given as L unit. Now radius of hemisphere is L by 2. Now radius of hemisphere. Now surface area of the remaining portion we can find out just by total surface area of the cube, that is 6 into edge square. Curved surface area of hemisphere, curved surface, this is 2 pi R square. Now minus area of the circular base of the hemisphere, just we subtract, and it is given 6 into L square, 2 pi L by 2 whole square minus pi L by 2 whole square. We just calculate, and this we got the result, L square by 4 pi plus 24 square unit. Now next question, we will see question number 6. A medicine capsule is in the shape of cylinder with 2 hemispheres stuck to each of its end. The length of the entire capsule is 14 mm and diameter of the capsule is 5 mm. Find the surface area. So in this question, first of all, this width is 5 and total length is 14. Now in the vertical way, if you will see the medical capsule like this, then there are 2 hemispheres. There are 2 hemispheres and 1 cylinder. So total length is 14, and up to here the length is 2.5. Here length is 2.5. So total length is from here to here 5. So the length of the cylinder is total 9, because 14 minus 5, this 2.5, this 2.5, that is 9 mm. This length is 9 mm. Now curved surface area of the hemisphere, that is 2 pi R square. Radius we know, and this is 2 parts. One part is this, one part is this. So 2 times of the curved surface area of hemisphere and curved surface area of the cylinder we can find out. So 2 pi r square, this is the value. Curved surface area of the cylinder portion 2 pi r h, 2 into pi by 2, 22 by 7. Radius is given 2.5 and height is 9. So this is 990 by 7. Now 2 times the curved surface area of one hemisphere portion, 2 times 275 by 7, that for the one sphere. So there are two hemispheres, so just multiply by 2. So this is 2 times plus this is the curved surface area of the cylindrical portion. So once we'll add, we get 220 millimeter square. This is the total required surface area of the medicine. A tent is in the shape of cylinder surmounted by a conical top. If the height and diameter of the cylinder part are 2.1 and 4 meter. Now from the figure 2.1 and 4 meter, this is given, and the slant height of the top is 2.8 meter. This is the slant height. This is the slant height. It is given 2.8 meter. Find the area of the canvas used for making the tent. Area we have to find out, and cost of canvas of tent at the rate of 500 per meter. Now, according to the given diagram, tent is the combination of the cylinder and cone. So first of all, whatever the different value of the different structure we have to find out. So for the conical portion, this portion, top portion, slant height is 2.8 and diameter, this is 2 meter. For the cylindrical portion, radius is 2 meter and height is 2.1 meter. So required surface area of the tent is curved surface area of the cone and curved surface area of the cylinder. So this is pi rl for the cone and 2 pi rh for the cylinder. Pi r is common and l plus h. So just substitute the value and we will get the surface area of the tent. So 22 by 7 into 2, this is length, slant height is 2.8 plus 2 into h. So this we got 44 meter square. Now cost of a canvas of the tent at the rate of 500 per meter square is surface area into cost per meter square. So 44 meter square we got the area into 500. That is total cost is 22,000 rupees. Now from a solid cylinder whose height is 2.4 meters and 2.4 centimeter. Now 2.4 centimeter is given. This is the height of the solid cylinder. Diameter is 1.4 centimeter. A conical cavity of the same height and same diameter is hollowed out. This is the part, conical cavity. Find the total surface area of the remaining solid of the nearest. Now cylinder is hollowed out in a conical cavity. So this is the conical cavity. In the conical shape it is hollowed out. So diameter of the cylinder first we have to find out. This is the diameter 1.4 centimeter. So radius is 0.7 centimeter. Now height of the cylinder is 2.4 centimeter. And height of the cylinder is nothing but the height of this cone, that is 2.4 centimeter. So slant height we can find out. Slant height is nothing but this is h and this is r and this is the slant height we can find out. This is 2.4 centimeter plus 0.7 centimeter this height. So we will get the value of the L. So this is 2.5 centimeter we got. Now total surface area of the remaining solid is curved surface area of conical cavity, curved surface area of the cylinder plus area of the base of the cylinder. This is the three part. So curved surface area of the cylinder is nothing but that is equal to the pi rl that we saw here. Height of the conical cavity, slant height is of the conical cavity. So curved surface area of the conical cavity plus curved surface area of the cylinder. So curved surface area of the cavity is pi rl. After that, curved surface area of the cylinder 2 pi rh and base area of the cylinder is pi r square. So each and every value pi r is common. So just we have to substitute the value This is L is 2.5, 2 into 2.4, and this is 18 centimeter square is the total surface area of the remaining solid. A wooden article was made by scooping out a hemisphere from each end of the solid cylinder, as shown in the figure. If the height of the cylinder is 10 centimeter and the base is 3.5 centimeter, this is given, then find the total surface area. Now, article is the combination of cylinder, first thing is cylinder, and two hemisphere. This is the structure. So height is 10 centimeter and radius of the hemisphere is 3.5 centimeter. So total surface area of the wooden cylinder is 2 into curved surface area of the hemisphere, this two part, plus curved surface area of the cylinder. So 2 into 2 pi r square plus 2 pi rh. Just we have to substitute the value. 2 into radius is 3.5 and height is 10. So this is 374 centimeter square. So in this way, you got all the examples, all the questions in the exercise. So just you revise these questions again and again and command on this. Thank you.